Hi everybody, welcome to another day of notes. Lots of things popping out. I didn't do a title page because I was just trying to make it quicker. Today we're focusing on one, no, and infinite solutions, and we are also covering, I can't talk anymore, covering the honors topic of absolute value equations. So regular, I'll say regular's done, you can just turn off the video. Honors, you will have to watch the video all the way through. Okay? So, this video should be very quick, because a lot of it's stuff that you guys already know. So, let's go ahead and jump into it. One, none, or infinite solutions. Basically, those are our special cases. We've already talked about one solution. That's where you just get like x equals 4. No solutions and infinite solutions are what you get when the variables end up canceling each other out, and you're left with an equation without any variables. So the two options are it can be true, which means it doesn't matter what the variable is, it'll always come out true, giving you infinite solutions. Or it could come out false, meaning no matter what the variable is, it will always give you a false statement. So there's no solution that works. Okay? But to do this, you just solve the equation like you normally would. So let's start with example 1. We have p minus 1 equals 5p plus 3p minus 8. You're just going to go ahead and combine your p's on this side. So you get p minus 1 equals 8p minus 8. Now you just need to get all your variables to one side and all your constants to another. So I'm going to go ahead and subtract p from both sides, giving me negative 1 over here. And then 8p minus 1p gives me 7p. So there, I got that. Now I'm just going to keep solving for p. I'm going to add 8 to both sides now. So now this is going to become 7. So 7 equals 7p. Divide both sides by p. I end up getting something. P equals 1. This is an example of one solution, and the way you would write it is in step builder notation. It's just p such that p equals 1. Okay? So that's your one solution. Solve the following equation. So first I'm going to distribute this negative 4. So I now have negative 4 plus 24a. Now I'm going to go ahead and get all my variables to one side. So I'm going to subtract 24a from both sides. I end up getting negative 22 equals negative 4. So here's an example where variables are gone, and I'm left with a false statement, because that's not true. So because it's not true, it means it doesn't matter what I put in for a, it'll always get canceled out, and I'm left with a false statement. So that means I have no solutions here. To write no solutions in set builder notation, you're basically just writing an empty set. There's nothing that'll work for a. Okay? So you don't have to worry so much about the set builder notation stuff, but no solution is when it doesn't come out equal and all the variables are gone. Okay? Then our third example, I think this is actually the wrong example. I was supposed to put in one for infinite solutions, but I didn't. So it's fun that way. So here I'm going to go ahead and distribute my negative 2. So I end up getting negative 2 minus 4, and negative 2x minus 4. And 4x minus 4 minus 2x. I combine my like terms over here, give me 2x minus 4. I now add 2 to both sides, which gives me, see, this should have been a negative 2. That's why. And these two x's cancel out, but these don't, so it gives me 4x. So let's keep solving. Add 4 to both sides. I get 0 equals 4x. Divide everything by 4. And I'm getting x equals 0. This does not mean no solutions. This is a one solution example. So to write it in set builder notation, I just write that. Okay? Now you're going to go ahead and try these 3 on your own. Give you a hint, there's 3 possible, there's 3 special cases, probably one of each. Okay? Infinite solution would just be if this was a negative 2 and we canceled it out, we get negative 4 equals negative 4. That's a true statement. It doesn't matter what x is. It would give me infinite solutions. Okay? So that's what it would look like. So go ahead and try these 3. Pause the video. When you come back, we will move on to the next part, which I think is just the honors part. Okay. So you should have done these 3. If you didn't, then go back and pause. These 3, we'll go over the answers for these next class. And yeah, if you have any questions, make sure you write them down. I think, yep, that's it for regular. So regular, you got less than a 5-minute video. Yay! Honors, sorry. Regular, you're done. You can close the video. And if you'd like to keep watching, feel free. Great minds. So the honors topic is absolute value equations. Remember that absolute values can only be positive numbers. Okay? So here are the 3 steps to solve an absolute value equation. We are going to isolate the variable using the inverse property, split the absolute value into 2 equations, and then solve both equations. Okay? So here's how we do it. We are trying to get this absolute value with the variable in it by itself. Okay? The whole thing with this, the absolute value must be by itself. Okay? We need to know what the absolute value equals in order to solve it. So I am just going to pretend like this is a giant variable and get it by itself. So I'm going to add 8 to both sides first. Oh, I did this wrong. I totally did this wrong. Crap. Oh. Well, now we're going to pay attention. Now, see, I did it on purpose. We're going to make sure you guys are using your listening skills. Oh, I did this so wrong. Oh, well. That's okay, Miss Scully. 28 plus 8 does not give you 20. 28 plus 8 gives you 36. Then we divide it by 2. So we get the absolute value equals, oh, that's going to bug me so much. What's half of 36? 18? Let me edit it. It doesn't want to let me edit it. Okay. I can move it, but I can't edit it. Come on. Yeah. Okay. So this should be 36 divided by 2, which would give me 18. Okay? So now that I have 18, that's going to stay there. I know what the absolute value is. So basically, everything inside this absolute value, when I take the absolute value of it, it should give me 18. Well, we're trying to think, what could the inside of this equal? The negative 2x plus 3 equal? That when I take the absolute value, it gives me 18. That would be 18. Negative 2x plus 3, if I replace that with an 18, the absolute value of 18 is 18. It also could be negative 18. So I'm basically taking what's inside the absolute value and setting it equal to either positive 18 or negative 18. And properties, don't like you. None. Let's change that. So that becomes 18. And this one becomes to you. This becomes an 18. Man, this just made it so much longer than it needed to be. And I gotta go to class. Oh well. So, now I go ahead and subtract 3 from both sides. So this gives me, not that. It gives me 15. Yep. And I subtract 3 here. So doesn't give me that. It gives me, what is that, 21? Yeah. Then I divide both sides by 2, or negative 2 rather. And it's going to end up giving me, this doesn't want to go away now. Not these answers. But instead, it gives me, go away now, don't care. It will give me negative 15 over 2 and positive 21 over 2. Those are my answers. And both are my actual answers. So if I was going to write this in step builder notation, I would write x such that x equals negative 15 over 2 and 21 over 2. Okay? So moving on to this example, which I did do correctly, I know that. I am still trying to get the absolute value by itself. So I need to get rid of this divide, or times negative 7. So I divide both sides by negative 7. There we go. And now I get the absolute value of x minus 14 is equal to negative 5. Ding, ding, ding. That should be, something should be going off for you. Can an absolute value equal a negative? No, it's not possible. You can't have an absolute value equal a negative. So because of that, because I got something that's not possible, that actually means I have no solutions. Nothing will work for this equation. Okay? No solutions will pop up all the time now. That's it for the video. Oh, wait, there's more. You guys have to try on your own, so you got to finish this. That's it for the video, though. Try these on your own. When we will go over them in class. Write down any questions. I will see you next time. Bye.